Hello everyone. Today our topic is uniform circular motion. See, if we broadly classify motion into two categories, it will be first rectilinear motion, that is the motion along a straight line, and circular motion in which the object is moving in a circular path. So far we have learned about the rectilinear motion. Now we'll look into the circular motion and specifically for the uniform circular motion. So, as I said, motion of a body along a circular path is a circular motion. Now, when the circular motion is referred as a uniform circular motion, it is referred as a uniform circular motion when the speed remains the constant. When the speed is constant, at that time, the circular motion is termed as a uniform circular motion. We'll see one example. See on the screen there is a girl who's holding a string. At the one end of the string there is a ball which is uh, revolving. Okay, the girl is revolving the string, so the ball is under the circular motion. Might be from the figure it is not seen as a circular motion, so we'll see the top view. See in the top view it is clearly seen now the ball is under the circular motion. Now, the ball will remain under the circular motion till the time she is holding the string. What will happen if the string is released? Suppose at this point the ball is released. If the string is released. If the string is released, the ball will go straight towards the A. Now, suppose at this point the string is released, then the ball will take a straight path like this. At this point, if the string is released, then the ball will take a path in this way. So, the object needs to be in a circular motion only when there is a force which is acting towards the center. Here, the force is applied by a girl through a string, and that is known as a tension. That is the tension. Now, the scenario is very similar when you're seeing a moon which is revolving around the earth. Now the moon is revolving around the earth because there is a central force acting, and that is a gravitational force. Similarly, the earth is revolving around the sun because there is a gravitational force of sun. So this force we are broadly named as a centripetal force. What is centripetal force? The centripetal force always keep an object moving in a circular path, and it is always acting towards the center. The word centripetal force come by the Latin word that is centrum, means the center, and the Peter means the seek. So this is a center seeking force, that is a centripetal force. Now, in the uniform circular motion, we have said the speed remains constant, but we didn't talk about the velocity. The reason being the velocity, the direction of the velocity is keep on changing. We'll see how. Now, for that, just consider an object which is moving along a circular track. Suppose the object started from A, it moved to the B, yes, with the uniform speed, and from B uniform speed he has to go to the C. But while moving from A, B to C, it has to change its direction. Again, at C, it has to change the direction again. So here, the object might be moving in a uniform speed, but the direction of the motion is changing 4 times. If the object is moving to in the hexagonal track, hexagonal means the 6-sided figure, here the object has to change its direction 6 times. In the octagonal shaped track, the octagonal is a closed figure which is having the 8 side, so the object has to change this direction 8 times. Now see, if you compare these figure, in the polynomial, we are increasing this side. As the side increases, it is more resembling to the circle. So, octagonal, you can see the dotted line, it is more resembling to the circle. So, more number of sides are there means the more number of times the direction of the velocity is changing. Here, at every point, circles are having the infinite point. At these infinite point, every time the velocity's direction is changing. So, the velocity you can see in this figure, see the blue line at every point when the box is moving in a circular path, the blue line representing how the velocity is changing at every point. So the first point is the direction of velocity keeps on changing, constantly changing. It's not going to remain same. Now, at a particular point, if I want to find out what is the direction of velocity, suppose here the object is, suppose at this point when the object will come, what is the direction of velocity? So at that point, definitely the object's velocity will be in this direction. This line which you are seeing is nothing but the tangent. Now what is tangent? Tangent is when you're taking a circle, a line which touches the circle at a single point at one point, that is known as a tangent. If you draw any line, suppose this is a line I have drawn, this touching the circle at 2 points. So this is not the tangent, this is a chord. So here the line which is touches the circle at a single point, that is a tangent. Now at this point, at particular point, at any point, the two tangents are possible. It can be in this direction or it can be in this direction. So which direction we have to consider while we are taking the direction of velocity? For this we have to take that tangent which is in the direction of motion. Suppose the object is moving in a clockwise direction. If the object is moving in the clockwise direction, at this point, we are going to take a tangent which is acting downward. If suppose the object is moving in the anti-clockwise, at that point the direction of the velocity will be on the tangent which is acting in an upward direction. So the direction of velocity is always towards the tangent. I hope you have understood about the tangent. In more, you will learn about the tangent in mathematics class 10th. Okay. Now the second thing which we need to learn is the speed. Now speed is distance by time. You know that if any object is moving in a circular path, if the object is starting at this point, if the object is starting from this point to complete one revolution or to complete one rotation or circle, the distance covered will be the circumference of an circle. The circumference of the circle, you know the formula, that is 2 pi r by t. So this is the formula for the speed. Remember, the speed of an object in a uniform circular motion is always constant. So v is equal to 2 pi r by t. It depends only on the radius and the time period. What is time period? Time period is the total time taken by an object to complete one circle. Now at this point we need to differentiate between the uniform motion which we have learned for the rectilinear. So specifically the uniform motion we are defining as the, or I have stated as a uniform linear motion, okay, and the uniform circular motion. So the first difference is in uniform linear motion the object travel in a straight line, that is a rectilinear motion. That's why in the uniform circular motion the object moves in a circular path. This is first is the definition. In the uniform motion or a linear motion, the speed and the velocity both are constant, whereas in uniform circular motion, the speed is constant but the velocity keep on changing. Remember, velocity is a vector quantity and a vector quantity has a magnitude and direction. Magnitude means the numerical value. Numerical value of the velocity is constant in uniform circular motion, but the direction is always changing. This is the reason why we are saying the velocity is changing, since the direction is changing. Now, since the velocity is changing in a uniform circular motion, the acceleration is also produced because the velocity is changing. You know that the acceleration is change in velocity in time. So if the velocity is changing, it is an accelerated. That's why the motion is said to be accelerated in uniform circular motion. Whereas the acceleration is zero because the velocity is constant, acceleration is zero. We'll see one numerical based on the uniform circular motion. If a radius of a dial of a clock is 10.5 centimeter, calculate the speed of the tip of seconds hand of the clock. Given pi is 22 by 7. You can use 3.14 also, but if you are taking 22 by 7, you have to see whether the calculation is going difficult or the easy. Now, see, there is a clock in which the second hand is moving. Now, how much time it will take to complete one circle? To complete one circle, it will take the 60 seconds. So time period I'm taking as 60 second. Suppose instead of a second hand it is given as a minute hand, what will be the time period? That will be 60 minute. At that time you need to convert to the SI unit. If it is a hour hand, what will be the time period? Then at that time it will be a 12 hour. You need to convert there also in the second. The radius is given as the 10.5 centimeter. Since the centimeter is not the SI unit, you need to convert to the SI unit by dividing with the 100. So 0.105 meter. You need to calculate the speed. Just now we have learned V is equal to 2 pi r by T. Substitute R and T, you will get 0.01 meter per second. Note the unit is compulsory to write. Without unit, the answer is incomplete. Speed of a tip of seconds hand of a clock is 0.01 second. So we have learned about the circular motion in this chapter. These are the few practice questions which you need to solve at home. Thank you.